Lab 9 using AWS to collect X dot data. The team members are Veda and Sukruth. What is a conduit? A multi-tech conduit is a versatile LoRa gateway that will help us in developing our IoT applications. So we are using a multi-connect conduit in our project over here, and it's very easy to deploy as well. So we are going to be using that, and in the conduit we are going to be using the Node-RED application. So what are the steps that we followed? So these are the steps. First, we connected the conduit to the power supply using an adapter, 9-volt adapter. Then we connected it using an Ethernet cable to our PC. Then after doing that, we opened a web browser and we went to the IP address 192.168.2.1, which is the default IP address of the conduit. And we logged in using the default credentials, which was the username was admin and the password was admin as well. And after making the initial changes, like the few steps which we got to set up the conduit, once we connected and logged in, we followed all the steps and we set up the conduit. And then on the left hand side, we went to LoRaWAN, and under that we went to the network settings, as you can see here. And then we set all of these parameters. The channel plan is US 915 and the frequency subband is 7, and the network mode is public LoRaWAN, and the joint delay is 5. So after doing that, let us go to the next step. So the next step is we went to the key management in the LoRaWAN settings itself here, this one. And after going there, we again changed all of these parameters. We made sure that the enabled is tick marked, and after that we kept the name as Smarty Pants, which is the name of our team. And we set the network key as passphrase, and the passphrase we kept it as Smarty Pants. So after doing all of this, we need to restart the LoRaWAN settings for the changes to take place, and we should see that the status of the network in the network settings should be running. So we went back to the network settings and we restarted the LoRa services, and as you can see, the status is up and running. You can see right here, it's in green. So after doing all of this, we went to the apps on the left side and launched Node-RED. So where can we find this? You can see it right here. We went to the apps, then you can find Node-RED under it. Then once we go to Node-RED, we logged in using the same username and the password that we used to configure for the conduit. And after doing that, we we dragged a LoRa node from the input to the flow screen, and we dragged a debug node in the output section to the flow screen, and we connected each of them, and we hit the deploy button, which was on the top, and we were in the debug tab here. Then we used AT commands to check whether our conduit is connected. So what we did was we first downloaded the AT command firmware, which we got from this particular link, and we imported it. So then we needed the xdot library in order to communicate with the peripherals on board. So we downloaded the xdot library, and while we were importing the library, we set the target path to .at firmware, which was name of the project which we gave while we were importing the .at firmware. And we just imported, and we selected all update everything to the latest revision while importing the xdot library. And after that, we downloaded the firmware. We compiled the file, the program, the .at firmware program, and with the compiled bin file, we put it into the xdot by connecting the xdot to our PC, that is our laptop. And after doing that, we hit the reset button. So we downloaded the putty application to interact with the xdot. So we downloaded the putty and we went to the control panel, and we went to the device manager, and under ports we checked what ports were assigned to the xdot. So we found that it was COM5, which was our UART port, and COM6, which was our the debug port. So we in the putty we made a serial connection to the UART port, that is COM5, and we gave the baud rate as 115200. And after that we made the serial connection, and once the putty established a serial connection, it was COM7, the UART port. We ran a set of 80 commands to set the network configuration. So we went ahead and did that, and as we can see, we are running each of the 80 commands. We ran 80, we got OK, then we gave the network ID as smarty pants, and again here we set the frequency subbands as 7, joint delay as 5, and then we sent 80 plus send equals Veda. So once we did that, on the debug port of the node red, on the debug tab of the node red, we received that particular message, as you can see right here. Then after that we wanted to send the data collected to the LoRa conduit. So what we did is we went ahead and downloaded the dot examples program from this particular link, and after that we needed to import the library called libex.embed5. So we imported the library, and while importing we set the target path as dot examples, and we tick mark the update all, update everything, update the sub libraries to the latest revision. Then we imported that as well. Then we went to the in dot examples we went to examples src ota example.cpp, and we made the following changes. So these changes were made in the code. As you can see, the network name is smarty pants, the network passphrase is smarty pants, and the frequency subband is 7, and the joint delay is 5. So after doing that, we made these changes as well. So in line 141 we put char array ee542, and we put this for loop for int I is equal to 0, I less than size of array minus 1 I plus plus, transmission data pushback array of I, and we sent this data using send underscore data, and we commented out the lines from 150 to 172. Then after that, when we compiled that program and put it into X dot and hit the reset button, then we established the serial connection using the putty to communicate. Then we didn't use putty over here, we just pressed the reset button, that's it. And since we are given char array as E542, once we put the compiled file into the X dot and hit the reset button, we were able to see EE542 in the debug port. It was printing on repeatedly, as you can see here, and we were able to verify that we were receiving the message on the Node-RED debug port. And after that, we needed to integrate the code from part 1 to the OTA example. So we were using a thermistor to do that. So what modifications did we make to the code? So modifications were this. So the beta value of the particular thermistor which we took was 3975, and that we set it over here in the code. And after that we copied this entire thing, the thermistor function, to calculate the Celsius value using the data from the thermistor. Then in int main we took up two variables. We set VCC as 1, and we took an unsigned int val. Then after that, here in the val we read the data from the thermistor into the val variable. Then a temp variable of data type double stored the return whatever the function thermistor of val returned, and we printed out the string using snprintf. And this is the connections which was made. So as you can see, we have used the X dot, and accordingly, seeing the pin configuration, we have connected the thermistor, and this is the way we have connected our sensor to the connected our X dot to our sensor circuit. And next, what we did is we opened the LoRa network settings, and we need to change the static LAN to DHCP. So we connected our conduit to the router which we had at home, and after that the DHCP which is inbuilt in our router will assign a dynamic IP address to the conduit. So we needed to know that particular IP address. So we logged into the ISP provider of a particular router, and there we checked the IP address which was assigned to our conduit, and we found that the IP address which was assigned to our conduit was 192.168.1.229. So we put the IP in the web browser and it opened up the same page of the conduit which you saw before, and we logged in using the same credentials, that is admin and smarty pants. The admin is the username and smarty pants is the password. The admin is the username and the admin is the password as well. And we went to apps, Node-RED, and we imported the flow which we used in the lab 8 using the JSON file, and we modified it accordingly to this particular lab. And what we did was, here we took a LoRa node and we connected to this format for BI stream. So format for BI stream, we are passing the message payload whatever we got, and after that we are converting into the float value here, because initially the data was sent in the string value, so we want to convert it into float. Then in HTTP request we are sending it to the EC2 instance which has the things board, by giving the URL of the particular EC2 instance, and that's about it. That is what we are doing right here. And as you can see, in HTTP module we have put the URL of your things board with appropriate token as done in lab 7. Then in the things board we have done the data visualization for different times. We can see the different temperature readings which we have got. This is part 1 of lab 9. So here we're gonna download the .at firmware, we're gonna import it, and once we are done importing we're gonna click on import. Okay, we're gonna choose a different file name, 1, and we're gonna do import, and we are importing the .at firmware. So once the .at firmware is imported, we are gonna need to import the library for that, and the library which we are going to import as libx.library. So here we are going to set the target path as .at firmware 1 and update all sublibraries to the latest version, and we're going to click on import. So we are importing the library now. So let's go ahead and compile this. It is going to take some time for compilation. Let's wait it out. And we are almost done with the compilation. Just a bit more. And we have compiled .at firmware 1.
At least 80 to 80 okay.
On the left bottom corner you can see the bin file. So we need to copy that bin file into the xrod. So we are going to go ahead and do that.
है कि 80 इसमें, फिर 80 से हम कनेक्ट करते हैं कॉन्टैक्ट्स, 80
One
कमांड्स
moment.
भेजते हैं कॉन्टैक्ट को. Like अभी we are not connecting to the conduit. Like we don't have any idea or awareness कि conduit है.
I have plugged in the X dot, and now I'm gonna go ahead and paste it here, the particular bin file. So I'm gonna copy this bin file and I'm gonna paste it on the in the X dot. So the program is now loaded into the X dot. So to see this, we're gonna need to use putty. So putty, using putty we can send messages, we can communicate with our X dot. So for that purpose, we're gonna go ahead and download putty.
अरे मुट्ठी डाल के निकालना.
Let me load it back again.
नाम लिखा है
Yeah.
सबके लिए, जैसे चुन
And the
चुन
.at
के
firmware 1 has been loaded into our X dot.
I think सब बार fail हो रहा था.
अभी हो रहा है.
Now we need to open putty. So we're gonna wait for that and we're gonna download putty. We're gonna see which ports are assigned for our debug port and the serial port. So as we can see, the UART port is COM8, so we're gonna be using that. So let's open putty. So we need to make a serial connection now. So we're gonna set it to serial and we're gonna use COM8 and the baud rate is 115200. So we're gonna set the baud rate to that and we're gonna open it. So we need to type 80 command now. If we get OK, then the connection is made and we got OK. Now let's go ahead and set the other parameters for our conduit using the 80 commands.
मैं इधर से जल्दी से फोटो ले लेती हूँ.
So these are the set of 80 commands that we are going to run.
So do 80 plus.
We're gonna type 80 plus
So 80
NI,
equals to 1.
that is network ID, and we're gonna set it to value 1 second.
स्टार्टिंग से क्लोज रेडियो.
Let's open it again. And we have opened 11520. We have opened another putty connection using the UART port. I have typed 80, then we are gonna set the network ID as network name as Smarty Pants, and the passphrase for our network is going to be Smarty Pants as well. Then we are gonna set our frequency subbands to 7. Then our join delay to 5.
ठीक है वो
and we are gonna join with this particular network, and we have successfully joined the network, and we're gonna send the data called hello, and it has been sent. We should see that on the debug port and the node red. And if you see in the debug port, we can see we have received. We're gonna deploy, and we're gonna see in the debug port that we're gonna type in hello again and send it back again because we just deployed it. And once we do that, we're gonna see hello over there on the debug port. So we can send any messages as such. And next we send E542 by making modifications to the code as given in our lab manuals. And then we're gonna head to the third part of sensing actual data and handling it. As you can see here, we have logged into the Spectrum page. The IP address is 192.168.1.1. This is the conduit which we have connected. Its IP address is 192.168.1.28. So let us go ahead and type that IP address and log into the conduit. So we are logging into the conduit now, 192.168.1.28. So once we log into once we type the IP address, we're gonna get this page. The username is admin, and the password is the one which we have set. So I'm logging in now. So after logging in, I'm gonna go to apps, and I'm gonna launch the Node-RED. So I've launched it, and this page we get, and again we're gonna need to type the username and password. Username is Party Pants. That is the name of our team, and the password is the one which we have set. So we are going to log into Node-RED. Sorry, the username is admin. Now we have logged into the Node-RED. We have imported the JSON file from our previous projects, and we have made modifications to it. So in the format for AWS block, we have made a modification. So the modification is we have called stringify, and we have used parsefloat to convert it to float value, and we have passed message.payload to it. So this is the modification which we have made. We have converted the string to float value. And in the HTTP request, the URL, we have given the URL of the EC2 instance which we created on Amazon for Things board, and it has the token value as this one. Let me just highlight it. Yeah, that is the token value. So from this we can successfully send the data to EC2 instance which we created on AWS. So that's about it for setting this up. Now let's go ahead and see what the program is that we need to put into the X dot. So we have connected our X dot to a thermistor, and I have imported this file. So the program is like this. The active example is OTA example. These are the credentials: smarty pants, and frequency band, subband is 7, and joint delay is 5, And furthermore, we have defined the beta value as 3975, which is the beta value for the thermistor which we have chosen. And we have the thermistor function to calculate the temperature from the data in terms of degrees Celsius. Then we have set VCC equals 1, and we have taken an unsigned int variable called val. Then after that, we have defined char out as 10, and we are reading the data into the val variable. Then we are calling the thermistor function and passing the val value, and we are pushing the data using the send data function. So these are the modifications which we did to our code. So that's about it. We're gonna go ahead and compile this. So once it is compiled, we're gonna put the bin file into the xstart and hit reset, and it should start. So now we have put the data, we have put the compiled bin file in the xstart, and we have hit the reset button, and our xstart is connected to the thermistor value. So as you can see on the debug port, we can see the different temperature readings at a particular instant of time. So the temperatures are going from 28.83 to 28.96, 24.20, 23.92, and the temperature readings are being taken in a contiguous manner. Let us take a couple of readings more. After this, we're going to send this to the EC2 instance, and we are going to make the analysis on the temperature readings using ThingsBoard, and we're going to create a graph. So we'll take another temperature reading. Yeah, one more, and we should be fine. And yep, we are good to go. We have created an EC2 instance, and we have loaded ThingsBoard on it. Now we are analyzing the data that we are getting from the conduit. So as we can see, it is giving temperature readings at different time instants. Let's go ahead and see the values of temperatures at different time instants. So we can see it is 24.29 over here, and we can see it is 25.98 at 1818 time, and so on. And again we can see it is 26.35 at 1818 time. Thank you for watching.